All right, and I'm back. And we're going to do some couple of practice here with some free body diagrams. I'm showing you how to draw them. And the first one, we want to show the free body diagram of this whole system, Ophelia and whatever the orange name will be, which I will name Paul. And what this looks like at constant velocity. Remember, constant velocity we should always underline, because Newton said that that means that the acceleration is 0, and because of his second law, if that's 0, that means that there is no net force. So if we look at number 1, what does it look like in terms of the Paul the apple? Well, Paul has his weight, and we'll say that the apple and the orange weigh the same. And he also has the normal force on him. He has friction pointing this way, which allows him to move his feet that way. But he also has an equal and opposite force there. So we should draw these two to be equal. And that is Paul. And remember, Paul is the orange. Paul has 4 forces, as does Ophelia. She weighs the same as Paul, so she has mg. She gets the reaction force here from Paul's pull. She has her normal force. And since it's friction, this pull must be equal to the force of friction. All right, and so she moves at a constant velocity, which Newton would say means this force and this force are equal. The opposite case would be if the apple is accelerating. And in that case, the pull force, or here, must be greater than friction. So everything looks the same for Paul. He has the force of friction from his feet, allowing him to go. He has his weight. And it seems I brought up the... Okay, Cortana. Go home.
Sorry, I didn't catch that.
Go home. Hey, Cortana. Go home.